I want to look at some of the end and local behavior of polynomial functions. And I'm going to start with end behavior. The end behavior is what's happening towards the ends of the function as x gets really close to infinity or really close to negative infinity. It's what's happening on the far left or the far right of the graph. And it's actually determined by two things: the degree of the polynomial and the sign of the leading coefficient, whether it's positive or negative. We'll need to know if the leading coefficient is positive or negative, and we'll need to know if the degree is even or odd. If the polynomial is even degree and my leading coefficient is positive, then both ends of the graph are going to go towards infinity. So the ends of the graph will look like this. For an even degree with a negative coefficient, it will be the opposite. Both ends will go to negative infinity. So the ends of the graph will look like this picture here. For an odd degree with a positive coefficient, we have the left side going off to negative infinity and the right side going off to positive infinity. For an odd degree with a negative coefficient, it will be the opposite. The left side will go up to positive infinity, and the right side will go down to negative infinity. So as long as we can figure out if the degree is even or odd, and if the coefficient is positive or negative, we can figure out what's happening on these extreme ends of the graph. Let's look at these four functions here and try to determine their end behavior. For the first one, 9x cubed plus x plus 8, the leading term will be 9x cubed. 3 is an odd power, so this is an odd degree, and 9 is positive, so it's odd degree with a positive coefficient. That means it will go down to the left and up on the right. For my next one, negative 6x squared plus 8, the leading term will be the negative 6x squared. 2 is an even degree, negative 6 is a negative coefficient. That tells me it's actually going to go down on both sides. My next one, negative 3x to the 5th minus 2x to the 4th minus 7x. My leading term here is my negative 3x to the 5th. This is an odd degree with a negative coefficient. That means it'll go up on the left and down on the right. Finally, f of x equal to 5x plus 2x squared. This time my leading term will be the 2x squared. This has a positive coefficient and an even degree, which tells me it's going to go up on both the left and the right. For local behavior, there are two types of things we want to look at: intercepts and turning points. Intercepts are where a graph crosses our axes, and then turning points are where the graph switches directions. Let's consider this here. Our intercepts are where we cross the axis. The x-intercepts are these 3 points where this graph crosses the x-axis, and the y-intercept is this 1 point where the graph crosses the y-axis. The turning points are where we switch direction. I've marked the 2 turning points here. These are also our local maxes and mins, but they're where my graph switches directions between increasing to decreasing or between decreasing to increasing. The degree of a polynomial can actually tell us a lot as well. For the degree of the polynomial, let's suppose that's n, the graph will have at most n x-intercepts. We can see that there are 3 here. So that indicates that this is degree 3 or higher. In addition, there can be at most n minus 1 turning points. The fact that there are 2 turning points in this graph tells us, once again, that this needs to be degree 3 or higher. In fact, this is degree 3.